So here's an example of a hyperbola that is not given to us in standard form. So what we're going to do is we are going to convert to standard form and then identify both the center as well as the orientation and whatever bonus math we feel like doing after that as well. So we have x squared minus 4y squared minus 6x minus 8y minus 11 is equal to 0. I'm sensing a lot of negativity in here. So here's what we'll do. First thing we need to do is identify that this thing is, in fact, a hyperbola. The fact that there's an x squared and a y squared indicates that it could be an ellipse, it could be a circle, or it could be a hyperbola. The fact that we have a positive x squared and a negative y squared indicates that they have opposite signs. That would be a hyperbola. If they had the same sign, it would be an ellipse, and if they had the same positive coefficient, that would be a circle. So first thing we need to do is do a little bit of regrouping. And the regrouping that we need to do is that we need all of the x terms together, and we need all of the y terms together, and we need everything that's not an x term or a y term, we need that to go ahead and go over to the other side of the equation. So we'll add 11 to both sides, and we'll separate out the x's together and the y's together. The reason we do this is because we need to complete the square. Now x is already ready to have its square completed. That's because the coefficient of x squared is 1. If the coefficient of your squared term is not 1, then we are not ready to complete the square. So with that in mind, the y squared has a lead coefficient of negative 4. I am going to factor out that negative 4 from both of the y terms. So what is actually happening here is, negative 4y squared, factor out the negative 4, and negative 8y, factor out the negative 4. So that should actually look like this, y squared plus 2y. Excellent. So with those things in mind, let's go about completing the square. So what we do is we grab our coefficient of the first power term, and we do two things to it. We divide it by 2, and then we square the result. What you get after you've divided by 2, but before you've squared the result, is the thing that you're going to see accompanying the variable inside the completed square. I will repeat that in just a moment. So what this is letting us know is, after we have squared, that we're actually adding 9 to the x squared minus 6x to complete that square. Whatever we do to one side of the equation, we have to balance it out by either doing the opposite thing to the same side or doing the same thing to the opposite side. We added 9 to the left side, let's add 9 to the right-hand side. We're going to do the same thing with the y terms. We're going to grab this positive 2, we're going to divide it by 2, and we're going to square the result. After dividing by 2, we get 1. After squaring the 1, we get 1. So inside the parentheses, I'm doing plus 1. Inside the parentheses is plus 1, but what did I actually do to the left-hand side of the equation? I did plus 1 with a coefficient of negative 4 that was factored out. So what I'm going to do to balance it out is say plus 1 times a coefficient of negative 4. So technically, by doing this plus 1, what I'm actually doing is subtracting 4 from both sides. A little confusing, but as long as you're following PEMDAS, all should be well. So to repeat what I said just a moment ago, this x squared minus 6x plus 9 is now a completed square, and we can refer to that as x minus 3 quantity squared. How do I know it's x minus 3? This number that we get inside the parentheses here should be the same as what we see right here with the x. That also allows us to draw a good conclusion about our y terms. Y squared plus 2y plus 1 will be y, and then that's a positive 1 here, so plus 1 here. 11 plus 9 is 20. 1 times negative 4 is negative 4. Negative 4, 20, that'll be 16. Now this is still not technically standard form because what we need to see is a 1 over here. And the way that we're going to get that 1 and necessarily introduce some fractions on the left-hand side, which is pretty common for standard form of a hyperbola, is we'll divide both sides by 16. We'll then take this 16 and distribute it through to both of the terms on the left-hand side. This x minus 3 squared had no coefficient, so that 16 is going to distribute through directly. For the second term on the left-hand side, that has a coefficient of minus 4. The minus sticks around, but then we can simplify the 4 over 16 to be an over 4. we'll also see a y plus 1 there. That'll be equal to 1. This is now the standard form of our hyperbola, completing the square and doing a little extra algebra. Let's see what we can conclude from this thing. So based off of the completed squares, we can identify that the center, if we set x minus 3 equal to 0, we'll get x is equal to 3. And if we set y plus 1 equal to 0, we'll get y equals negative 1. The fact that x comes first means that we are dealing with a horizontal transverse axis. That also indicates that the 16 that we see is the value of a squared, telling us that a is going to be equal to 4. This 4 refers to b squared, so b is going to be equal to 2. If we wanted to do the additional algebra of figuring out the c value, then we definitely could, but that will be left to the viewer as an exercise.